BC Chemistry, Unit 4. Now let's talk about the F word, fats and oils. Okay. These two pictures, which one is more kinky? You'll be like, okay, this guy looks really kinky. What's going on there in that blood vessel? But actually, that's because of consumption of a less kinky fatty acid. And in this case, this guy is probably consuming a lot of quite kinky fatty acid and resulting in a very healthy blood vessel. Now, what are fats and oils? So fats and oils, they belong to the lipid family, together with waxes and steroids. Okay. All members of the lipid family are insoluble in water. They contain mainly hydrogens and carbon, but they also have a small percentage of oxygen, very small. Fats and oils have similar chemical makeup. They are basically triglycerides. Okay. Remember we talked about triglycerides when we were talking about biodiesels, as they are actually the ingredient of biodiesel. Fats and oils are distinguished simply on the basis of their physical state at room temperature. So if you are solid at room temperature, you're fat. If you are liquid at room temperature, then you're oil. Okay, so some kind of fat or / oil, like coconut oil, you'll notice that in summer, your bottle of coconut oil at home will be oil, right? But in winter, if you look at it, it's probably a bottle of fat. Okay. Triglycerides. So triglycerides are formed through a condensation reaction between an alkanol called glycerol. You have a 3 carbon connected together with 3 hydroxyl groups. It's literally 1, 2, 3 propanediol. Okay, and also you need 3 fatty acids to go through a condensation reaction. So because you have 3 hydroxyl groups and 3 fatty acids, you will produce 3 water and 3 ester linkage. Right? So this is your glycerol, this is your fatty acids. They are connected by that ester linkage in the middle. Okay. Now, condensation. Another look. Okay, so 1 glycerol, 3 fatty acids, then 3 water is formed and 3 ester links are produced. Now, transesterification, if you still remember, that is the reaction that we use to actually produce biodiesel, right? So esterification reaction between glycerol and 3 fatty acids. Fatty acids are just the acids with really, really long hydrocarbon chains. Okay? So 3 fatty acids and 1 glycerol produce 1 triglyceride. Then this triglyceride is our ingredient to make biodiesel. What do is that we're trying to swap out that glycerol molecule with 3 molecules of methanol. So in the end, under a base as a catalyst, so KOH or NaOH as a catalyst, you heat it up, you put them together, heat it up, add your catalyst. In the end, glycerol is swapped out as 1, 2, 3 propanediol now, and then these 3 the methyl part gets attached to the 3 fatty acids individually. So we produce actually 3 fatty acid molecules. Okay, so you notice that 3 ester linkage, we want to break all 3 of them, and therefore we can free up these 3 fatty acids to become individual molecules. And then the glycerol molecule is now here, and then this part, the CH3O part, is attached to each of the fatty acid molecule. Okay, so that's transesterification. Now, triglycerides normally have 3 different fatty acid chains. Some of these chains may contain carbon-carbon double bond. Okay, so here when we talk about double bond in the fatty acid chain, we have to be very, very specific, because all fatty acids will have a double bond. that is the carbon-oxygen double bond. But if we want to refer to that double bond in their chains, we have to specifically say that that's a carbon-carbon double bond. That's what we care about, right? We don't care about the common part, which is the carbonyl group, right? So in this case, your fatty acid in this triglyceride is a saturated fatty acid. You will see that even for saturated fatty acid, your carbon-hydrogen ratio will always be CnH2n plus 1. Of course, the other hydrogen is here, right? Okay, so you also have a carbon. So it's essentially like 1:2 ratio in terms of hydrogens and carbons when it's saturated. If you have one carbon-carbon double bond in the hydrocarbon chain, that is a monounsaturated fatty acid. And then sometimes you might have multiple carbon-carbon double bonds, then it becomes a polyunsaturated fatty acid. Okay? So the key is that every carbon-carbon double bond will result in 2 less hydrogen. As you can see that from saturated to monounsaturated, we lose 2 hydrogens. And from polyunsaturated, depending on how many carbon-carbon double bond you have, then the hydrogens just keep dropping. Now, saturated fats. For saturated fats, they're mostly made from saturated fatty acids. So the triglycerides only have saturated fatty acid chains. Okay? They occur in higher proportions in animal fats. In plant oils, as you see, we call it oils. Okay. So in plants, we see more of that unsaturated fats. Okay. So saturated fats are generally unreactive. They exist as waxy solids at room temperature. Unsaturated fats. Unsaturated fatty acids are classified according to the position of the first double bond from the end of the hydrocarbon chain. Okay. So in fatty acids, the carboxylic end is regarded as the start of the fatty acid chain. Therefore, that carbon is the alpha carbon. Okay. You can see that carbon in the Q is the alpha carbon because that's regarded as the start of the chain. So the other end, we call it the omega end. The methyl group end, we call it the omega end. Okay. So, but interestingly, when we try to name unsaturated fatty acids, we actually count the first double bond from the methyl group end, the omega end, to name this entire fatty acid chain. So for example, for this particular fatty acid, we notice that from the omega carbon, basically the end methyl group, the end carbon, there's 1, 2, 3 carbon. The double bond occurs on the third carbon to the CH3 end, to the methyl end. And therefore, this entire fatty acid is classified as omega-3 fatty acid. Yes, this is that famous omega-3 fatty acid that normally appears in, tuna cans or like some seeds and some other healthy food. Okay. So you can imagine that similarly, omega-6 refers to the fatty acid with carbon-carbon double bond, first occurring on the 6th carbon counting from the omega end, okay, from the methyl group end. Okay. So why do we specifically talk about omega-6, omega-3 all the time? It's because that our body cannot produce omega-3 or omega-6. Okay? So that's why they are classified as essential fatty acids. Okay? We must obtain them from food. So in this entire unit, whenever we talk about something that's essential, it probably means that our body cannot produce them, and therefore we must obtain any of those essential components from the diet that we have. Okay. So a final recap, all the fatty acids with double bond starting from the third carbon from the methyl end is called omega-3 fatty acid. And all the fatty acids with the first double bond occurring on the 6 carbon from the methyl end is omega-6. Now, a note on omega-3 and 6. So we talk less about omega-6 is because it's easier to obtain from vegetable oils. However, omega-3 is much rarer. Only fish oils or some seeds have or very particular type of lamb will contain them. So most researches regarding the healthy benefits of omega-3, they are not scientifically rigorous, but recently some researchers suggest that it may be the ratio of omega-3 to omega-6 that plays a significant role on health.